Hello everyone, my name is Benedictus William Chakerti from Class A with student ID number 2024-32017. In this video, for the web programming course, I will demonstrate a web-based information system that I have developed called LabVentory. Alright, let's start with the foundation of our application, the database. First, we have the users table, which stores login credentials, the user's full names, and handles our role-based authentication, separating admins and regular users. Second, there is the barang table, which acts as our master inventory to record the item names, available stock, and specific laboratory locations. And third, the peminjaman table, which manages the transactional relationship between users and the items they borrow, complete with automated tracking for request status and timestamps. All relational constraints are set up with foreign keys to maintain data integrity. Moving on the code, let's look at admin PHP. These files serve as the main dashboard for our laboratory assistants or administrators. At the top of the files, this file contains three major dynamic sections. The first section handles the create functionality of our CRUD system, allowing admins to add new items into the database. The second section processes a relational SQL query to fetch and display the master data inventories in real time. Lastly, the bottom section handles the core approval workflow, pulling live data from the borrowing requests, where admins can seamlessly update transaction status with a single click. We have a very simple yet crucial file. This acts as the default entry point or the traffic controller for our web application. Instead of showing an empty directory or raw files, we use PHP native header direction to automatically forward any visitor straight to the landing page or the authentication gate. It keeps our application entry smooth and professional. Next up is Connexy PHP. This is a highly modular file that acts as the central bridge between our PHP application and the MySQL database server. Instead of rewriting the database connection string in every single file, we centralize it here using the MySQL connect function. It specifies our hostname, database, username, password, and the database name we created earlier. It also contains an error handling statement that will immediately halt execution and display an error message if the connection ever fails. Now let's talk about login PHP. The key highlight here is the implementation of our role-based access control. Once a user successfully authenticates, the system checks their role field. If the role is admin, the script initializes a secure session and redirects them straight to the admin dashboard. If the role is user, they are smoothly directed to the student portal. It also features client-side from validations and dynamic alerts to inform the user if they enter incorrect credentials. To accompany our login system, we have Logout PHP. Security is a top priority, so this file is dedicated entirely to safety, destroying active user sessions. When a user clicks the logout button, the script clears all registered sessions variables and completely terminates the session on the server side. So finally, it securely redirects the user back to the login page, preventing anyone from using the browser's back button to access restricted dashboards illegally. Lastly, for this section, we have Register PHP, which provides a self-service registration portal for new students or lab practitioners. On the back end, this file executes a two-step verification process. First, it runs a validation query to check if the requested username is already taken. If it's unique, it proceeds to execute an insert statement to add the new practitioner to the users table. For security and system design integrity, the registration script automatically locks the account role to user, ensuring that a newly registered account can never grant itself administrative privileges. The final piece of our codebase is User PHP. This serves as the dedicated portal for our students or lab practitioners. Similar to the admin panel, it begins with a secure session check to ensure only authorized users can view this page. Structurally, it features a clean layout designed for the new student workflow on one side, it requires the database to display a real-time catalog of available lab equipment, including livestock numbers and their exact lab locations. On the other side, it contains a simple form allowing students to select an item, input the required quantity, and submit a borrowing request. These requests are directly piped into our transaction table awaiting the administrative approval. Now that we've reviewed the code, let's jump into the live demonstration. Welcome to the homepage of LabVentory. As you can see, the landing page greets users with a modern high-contrast dark theme. Looking around the interface, we have our branding logo at the top left and a prominent login navigation button at the top right. In the center, we have future clear information card representing the laboratory ecosystem, highlighting specialized division like software engineering and intelligent computing. Okay, so now I will go into the login page and enter the username of admin and then enter the password. So this is the example if I entered the wrong password. First, let's add a switch hub. With 3 units, and for the software engineering. And the second, we will input a monitor with 15 units allocated to the intelligent computing. The third, we will input a keyboard Logitech with 13 units for software engineering. And the fourth, we will add Arduino Uno with 10 units of stocks for intelligent computing. And then last is Kisco with 5 units for the software engineering. All items are now registered in our master data inventories table with their respective stock balances and correct laboratory badges. Okay, so now in this portal, the student can see the real-time catalog of the 5 items we entered as an admin. Complete with their current stock levels, let's simulate a couple of borrowing requests. For our first request, I will select the Arduino Uno R3 from the drop-down. And submit it. Our sweet alert notification pop-ups confirming the request is sent. Now I will log out to this and enter the admin panel. As we can see in this list of borrowing student, table is no longer empty. The leave requests from our student Benedictus William Wijakerti are now visible here. To demonstrate the robust status workflow of our application, let's process this directly. For the pending status, we leave our switch hub 8 port completely untouched. It remains as pending in the system, meaning it is still waiting for review. The second, for Arduino Uno, I will click the approve. The page reload and the status instantly updates to approved which automatically reduces our available inventory stock. Third, for the rejected status, let's look at the KISCO router. I will click the reject button, and the status changes to rejected, leaving the inventory stock untouched since the item was never given out. For the return status, for an item that was previously approved, for example, for the monitor, and I will click the return button, and the status changes to return, and our backend automatically restores the item stock back to its original balance. Now I want to test the security and data integrity of our relational database structure. What happens if an admin accidentally tries to delete an item from the master inventory while it is still actively being borrowed by a student? Let's try to delete the Arduino Uno. And the deletion fails completely. This is because we have set up a strict foreign key constraints metric in MySQL between our tables. The database prevents data corruption by ensuring you cannot delete an item that is still bound to an active transaction record. This keeps our laboratory data perfectly safe and consistent. To wrap up our live system workflow, let's jump back one last time into the student's perspective to see how these changes reflect on their end. I will log out of the admin panel and log back into the student account. Now looking at the student personal transaction history table, we can see that the updates made by the admin are beautifully synchronized in real time. The student can clearly track which of their requests are still pending review, which ones were approved, which ones got rejected with the inventory securely intact, and which items have been successfully logged as returned to the laboratory. Everything is perfectly integrated, transparent, and completely responsive. And that concludes the entire walkthrough and live demonstration of the LabVentory system. I hope this presentation provided a clear insight into how the system functions. Thank you so much for your time, for your attention, and for watching this video. Have a wonderful day ahead, and goodbye.